All right, here I'm making a video on Kirchhoff's rules just to avoid the confusion. So if you listen to this video and follow me, it should be really easy. Kirchhoff's rules are used to simplify a complicated network in finding the currents and the voltages through different components or across different components. So these are the rules. The first rule is applied to an electrical junction. It's called the Junction Rule. And according to this rule, the sum of all currents entering the junction must be equal to the sum of all currents leaving the junction. So the total current coming in is equal to the total current going out, which means that there is no collection of electrical charges at any junction. What comes in goes out. And Kirchhoff's second rule is called the loop rule. And in this rule, the algebraic sum of changes in potential around any closed circuit must be zero. So when we hear about the algebraic sum, which means we have to consider the sign of the changes in potential. That's where it becomes a little complicated, but let's simplify this. So here are the Kirchhoff's rules, 1 and 2. That's applied to a simple circuit first. But before that, this is the first rule. Currents coming in. I1, I2 and I4 are coming in. As you can see, I1, I2 and I4 flowing in, while I3 and I6 are flowing out. So I1 plus I2 plus I4 is equal to I3 minus I6. So now the loop rule, let's apply it to this case, and we will always go clockwise through a circuit. And if you're going in the direction of the current, you take it as positive. Keep it as positive. So this current I, which is shown here, is actually flowing this way through the whole circuit, right? That's how this current is flowing. And that's exactly the direction in which we are going across the loop. Therefore, when you go through R1, it's going to be positive I1 R1. Through R2, again positive I2 R2. And then across R3 is again positive I R3. When you come to the battery, you come to which terminal first? You come to negative, right? So you put it as negative 12. So when you go across the loop, for the battery, there's a separate rule. That is, whatever terminal you come to first, that's the sign you will give to the voltage. So when you write it down for this one, it's going to be like this. So there are two sets of rules. For the voltage drop across the resistances, the rule is that if you're going in the direction of the current, you keep it positive. So IR1 plus IR2 plus IR3. But when it comes to the battery, the rule is you look at what terminal you come to. Okay, you're coming this way, and you're coming to which terminal? You're coming to the negative, right? So write it as negative 12 is equal to 0. All right, I think that should make sense. Of course, if you take the negative 12 to the other side, it's going to become positive 12. Well, let's try it again in this circuit. The junction rule should be clear. I1 is coming in, I3 and I2 are flowing out. So I1 is equal to I3 plus I2. And that's the same case whether you apply it to B or to junction E. All right. Now, if we try to apply the loop rule, I1 R1, we're going clockwise. and we are applying it in the mesh ABEFA. So it's ABEFA. So in this loop, or I think I used the word mesh, MESH. So that's another word for loop. So ABEFA. Aren't we going in the direction of the current here? So it's positive I1R1. Are we going in the same direction as the current when you go down? Yes. So it's plus I2R2. And then when you get here, aren't you coming to the negative terminal? So it's negative V is equal to 0. That's it. Okay, so now what I've done is I've taken the negative V is equal to 0 to the other side. That's why it became positive. Let's try it one more time in BCDEB. BCDEB, that should be easy because we're going clockwise again. We're going down through this, and that's the direction in which current is flowing. So it's positive I3R3. And then when you come here, you're going this way, but the current is coming opposite to what you're going. Therefore, it should be negative I2R3. I2R2 should be equal to 0. Why equal to 0? Because there are no voltage sources in this loop. There is no battery in this loop. That must be clear. But maybe one more. Alright, this is just to show that you can apply it in different loops. In fact, you can apply it to 3 loops, but just 2 combinations will do. Okay, either these 2 loops or the first left one or the total loop, the outer loop. So just 2 loops are enough. You don't have to apply it to 3. That's what it says. Okay, so here, let's try to get this one last time to make it clear. And the junction rule is easy. That's understood. I1 coming in, so positive, minus I2 minus I3 is equal to 0, right? Or I1 is equal to I2 plus I3. Okay, now let's look at loop ABEFA. In this loop, we're going clockwise. We'll start from here, and the current is going the same way as we are going. So it's plus I1R1 plus I2R2. And then when you come here, what terminal of the battery are you coming to? Negative. So it will be negative 24 is equal to 0. And when you take that negative 24 to the other side, it becomes positive. So by now it should be clear. Let me write it down. I1R1 plus I2R2 minus I1 is 0. That's the one. One more. Let's apply it in the loop EBCDE. EBCDE. All right. We're going clockwise. As always, we'll go clockwise. And then we'll start from here. So are we going in the direction of the current? Yes, we are. So it'll be plus I3R3, right? Plus I3R3. And then as we're going down this way, plus I3R3. Are we going in the same direction as the current here? Got to be careful. What is the current through this? It's I3. It's the same current because these 2 are in series. So yes, we're going down the same direction. So it'll be plus I3R4. All right. You come to the battery. What terminal do you come to? Positive. So it'll be plus 29. Right? And then when you come back up, you're going opposite to the current. So it'll be negative I2R2. All right, let's write it. I3R3 plus I4R4 plus V2 minus I2R2 is equal to 0. Oh, I mean, I made a mistake there. Now, you can, of course, take the common factor out. I3 is common. And then you can take V2 to the other side, which makes it negative V2, okay? Now, if you have an equation, it is okay to change the signs of all the terms. So there are 3 terms here. Change the sign of all of them, it'll be okay. So that's what we're going to do next. And then this is going to become positive, so I'm going to write it first. This is negative, and then this is positive. So I've changed the sign of all of them, and that gives you that equation. So by this, Kirchhoff's rules and their application must be quite easy. Well, of course, after you get those equations, you need to solve them. All right, thank you so much. I hope you have understood Kirchhoff's rules.